Right, again, here we go, another element, Yttrium, down here, our next element. Now, Itrium, let's have a look at the card, and let's have a look at its atomic structure. Number 39, so it's got 39 protons in the centre, a bunch of neutrons, and 39 electrons going around in a cloud, in an orbit around it. They are really important to today's card because we've got lasers, we're talking about lasers. And you need to understand about light and where it comes from. And it's everything to do with these electrons and what they're doing, whizzing around. Anyway, now it's called Itrium after a town called Ytterby in Sweden. Here it is on the map, in a quarry, in a mine. And it was discovered by a chemist who handed it over to a Johann Gadelin. I think I'm pronouncing that right, in about 1789. And he had a lump of black rock that he analysed, and there was loads of elements in there. I think there was about 4 elements in there. Now, here's a picture of, it's not found in its natural form, by the way. It's too reactive. They're all pretty reactive over here, if you remember that. And here it is, once it is isolated, it's silvery, soft, and if you cut it up, it will burn ferociously. It's the brightest light, I think it is, that any element can make. And it was used in gas lights and street lights. And it was also used to make the red colour in a TV, on the monitor, on a screen. But let's have a look at the card. Let's have a look at the card enlarged. Now, first of all, in the background, we have a huge fan. Where's that from? That's from a jet engine. In the side of a jet engine, you have huge fans, which compress the air. And they get put under tremendous pressures and heats, and they have a layer of yttrium on them to protect them from unburnt fuel and oxygen. So, and it's really weird how it works because, okay, talking about rust or oxygen, you know what rust is? Iron, for example, over here, that gets rusty, it crumbles and falls apart. But you're not destroying the atom itself. The atom is still okay. In fact, iron is the stablest atom that there is. It crumbles though. The atom's still there, but it's crumbling. It loses its structure together as a crystal. Does that make sense? Anyway, but not all rust is bad. In fact, a thin layer of rust called oxidization, have a look at this, here's some metal, here's a thin layer of rust. And that thin layer of rust will therefore protect the stuff underneath it from further damage. And that's what they use yttrium in aeroplane fans. Now, next thing is lasers coming out of his eyes. So, I'm going to try and explain in a few minutes how a laser works. Let's go for it, because they're really cool. Now, let's have a look at the atom again. Now, you see these electrons. The first thing to understand is where light comes from. Now, here's the spectrum, if you remember. We have gamma radiation over here, radio waves over there, and all sorts of other things. But in the centre is visible light, what you can see. But what is light? It's a wave, a packet of energy. Where does it come from? It comes from these electrons. When they get excited, thank you, Mary. When they get excited, they move from one of these orbits, they're called, one of these circles, to a higher orbit. That takes energy. And when they fall back down, they produce a photon of light that then leaves the electron and goes on its journey at 300,000 kilometers a second. So that's light. Now, here's our laser. You need to know that to understand a laser. Now, lasers were first thought about by Albert Einstein a long time ago. He had the concept of a laser, but it was only in the 1960s that they made the first laser, and they used a ruby. Now, okay, here's a tube. Here's a ruby. I wish it was a real one, that's massive. Now, you can use solid liquids, solids, liquids and gases to produce a laser, but the important thing is light must be able to pass through it. So how does this work? First of all, with our tube of ruby, we have to pump it. We have to excite the atoms inside the ruby so that the electrons go up a higher level. And they use an external light source and they start pumping it. This excites the atoms inside. And when they get excited, the electrons go up a level. Now, here's the clever thing. When the light travels down the ruby, if it is going in a certain direction, it will hit a mirror. We have two mirrors either side. So that's the next thing in our laser. Now, if one of these photons of light flies down, hits a mirror, bounces back, here's the very clever part. If that photon of light hits that electron, which is at a higher level, it will force that electron to fall down to another level. But here's the smart thing. It produces another photon of light. And that photon of light is the same color and, more importantly, going in the same direction. So now we have two photons of light coming down our ruby. They hit the other mirror and return, bounce into two more electrons. And you've got to remember, this is happening incredibly fast, over 300,000 kilometers a second. So very soon, if it doubles, every time it goes through the ruby, bouncing between the two mirrors, you're going to get billions and billions of photons of light, laser light, bouncing between the two mirrors. And there's your laser light. So the last question is, how does it escape from the ruby? Well, one of the mirrors is really reflective. It reflects all the light. And the other mirror is, say, 90% reflective. So 10% of the light will go out. That's your laser. And the other 90% of the light will bounce backwards and forwards between the mirrors, continuing this chain reaction. There's a laser. And laser means something. It means light amplification of stimulated emission of radiation. It's a bit of a mouthful, but now you understand, sort of, I hope, how a laser works. And of course, lasers are in all sorts of movies. For example, we've got Cyclops from the X-Men. We have Superman, lasers come out of his eyes. And of course, it's very important for saving planet Earth by cutting open fridges and finding small plants. Isn't that right? Cute. So, where does yttrium come into this laser? Well, the example I gave you was a ruby, but there is a thing called a YAG laser. And now a YAG lasers are made of yttrium, here it is, aluminium over here it is, and oxygen. Those three things make this special garnet, like a crystal. And that's used for all sorts of things. Eye surgery amongst them. Cutting things that can be very powerful. But they're also used for entertainment, all sorts. And barcode reading and optics and communications. It's lasers are really important technology. So I hope I've explained that reasonably well. Cool. So there's Itrium. And then next time we'll be doing this one. See you next time. Bye.